Parent functions and transformations. Use transformations to graph each of the following functions on the coordinate plane. Then state the domain, range, end behavior, and equations of any asymptotes. Example 1. Y equals 3 times the quantity x plus 1 squared minus 5. Because this is from the parent function y equals x squared, I know approximately how it's going to look. I'm looking at what is subtracted from the x, that is negative 1, and subtracted from the y is negative 5. Remember the HK form, the vertex form of the parabola, where HK is the vertex of the parabola and A is the multiplier. So I know that my new vertex is at negative 1, negative 5. Left 1 and down 1, 2, 3, 4, 5 is where the vertex of the parabola is. Now normally, in the parabolic function, the quadratic function, 1 squared is 1, 2 squared is 4, 3 squared is 9, so on and so forth. So that means when I move 1 unit away, I normally go 1 unit up, since 1 squared is 1. But because I'm multiplying by 3, I'm going to multiply each of these by 3. So I'm going 1 unit over and 3 units up in both directions. And I'm going 2 units over and 12 units up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Little bit off the map, but we can still get the idea of how it's quite stretched out. And then I can do a smooth connection of the points to create the curve. What is the domain of a quadratic function? All real numbers, of course, because to the left and right the function goes forever. What is the range? Starts down here at its minimum point, which is negative 5, and goes up forever, positive infinity. What is the end behavior? As x goes to negative infinity, meaning as we look to the left, the function f of x keeps going up forever, so it goes to positive infinity. As x goes to positive infinity, the function f of x also keeps going up to positive infinity. There are no asymptotes in a quadratic function. Example 2, y equals 2 e to the x minus 4. So we remember the parent function, y equals e to the x, looks like this. Major point to remember on the exponential function is the point 0, 1, because e to the 0 equals 1. There's also an asymptote along the x-axis at y equals 0. So notice, because of the minus 4, that asymptote is going to be shifted down 4 units. 1, 2, 3, 4. So I'm going to draw my asymptote here at y equals negative 4. Because that point is normally 0, 1, but I'm multiplying by 2, that point becomes 0, 2. So that means 2 units above the asymptote. Now I can find more points to plot, but I know generally the exponential function behaves like that. What is the domain of the exponential function? Always all real numbers. The range goes from the asymptote, negative 4, but it does not reach the asymptote, so it's an open bracket, and then goes up forever. The end behavior, as x goes to negative infinity, so looking to the left, the function is approaching the y value negative 4. As x goes to positive infinity, or rather looking to the right, the function goes up. So it goes to positive infinity. Y equals negative natural log of x plus 1. So again, we recall the parent function, y equals natural log of x, which has a vertical asymptote at x equals 0, and looks like this, with the very important point of 1, 0. Now because x plus 1, this is a shift left 1 unit. So this vertical asymptote moves over to the left 1 unit and is now at x equals -1. Also, this point 1, 0 is shifted left 1 unit, or it's just 1 unit away from the asymptote to the right. Now the negative is a multiplier by -1, or we can think of flip it over. So instead of the function looking like this, the function looks like this. What is the domain of the log function? Well, it can't reach -1, but it goes close to it, and then it goes to the right forever. The range, well, it keeps going down forever, so -infinity, and the highest it goes is up forever, +infinity. As we look to the left, as x goes to -infinity, well, it doesn't go to the -infinity. The farthest to the left it sort of goes is -1. So f of x goes to infinity because it goes up there. As x goes to +infinity, or looking to the right, the function keeps going down forever. The function goes to -infinity because we say it keeps going down forever. Example 4, y equals 2 over x plus 1. This comes from the parent function y equals 1 over x, which looks like this. Two asymptotes for this function, one at x equals 0 and one at y equals 0. Because of the plus 1, this graph is shifted up 1 unit. So going up 1 unit makes the new asymptote at y equals 1, but the old asymptote, x equals 0, for the vertical asymptote stays the same. So we've got y equals 1 and x equals 0. Now we've got a multiplier of 2. Think of this like it says 2 times 1 over x. So normally where I'd go over 1, end up 1, I'm going over 1 and up 2, or left 1 and down 2. But for the most part, I want to just try to follow the asymptotes, stay close to them, and keep getting closer. Domain and range. Looking to the left, the function goes to the left forever, and it approaches 0 and never hits it. So we break up the domain at 0. The range, the function goes down forever, but similarly to the domain, doesn't quite get to 1 and never reaches 1. The end behavior, as x goes to -infinity, the function is getting closer to 1. Looking to the right, as x goes to +infinity, the function is also approaching 1. Have fun graphing the parent functions.